Okay, so this is after we took a break to prove beyond a shadow of a doubt that sine of 30 degrees, whoops, I just said, I was about to say 1/2, but I wrote 1/3. Sine of 30 degrees is 1/2. So now we know, even beyond looking at the graph where we say, oh, okay, y is like 1/2.
Looks like
okay, we now know for sure that sine of 30 degrees is 1/2. Now, problem number 2, sine of 45 degrees. Okay, apparently we're supposed to use the graph, so let's go in. How can I label 45? Where's 45? How about halfway between 30 and 60?
Okay.
Does that make sense?
Mm-hmm.
Okay, so we got 45. There's 45, and now remember how we said sine was the y-coordinate? That's on the unit circle. Sine is also the y-coordinate on this graph, but that's just a coincidence of the way that we graph things. Okay? So, as it turns out, this graph is supposed to be a graph of y equals sine x. Okay? Here was 0.5. Here is 1 on the graph. And they want us to say, okay, using the graph y-coordinate, not the y-coordinate of the unit circle, using the graph y-coordinate, what is sine of 45 degrees?
The sine of 45 degrees.
Well, for that, okay, we could look at it on the graph. Okay, how far do you think this is? If this is 0.5, how far do you think this?
Looks like 0.7.
Right. Okay. Yeah. So let's say this is 45 degrees, and then about 0.7. Right?
Yes.
Okay, do you know what sine of 45 degrees is from knowledge of the unit circle? So we studied this last week and the week before. Sine of 45 degrees, officially, not using the graph, sine of 45 degrees is what? Do you remember? There's a square root in there.
45 degrees. The square root of 3 over 2.
Square root of 3 over 2? How do you figure it out? All right, let's do it. No, let's figure it out. 45 degrees. I'm going to do this one a little bit faster. But 45 degrees here makes us a right triangle.
Yes.
Right? And what is so great about this right triangle is that we have a same on the legs, right? Because as soon as I fill in 45 degrees here and 90 degrees here, I've got no choice but to fill in 45 right here.
Okay.
Right? Which means this triangle, whatever it is isosceles, because this side is the same as that side. Okay?
Mm-hmm.
Does that make sense there?
Yes.
Okay. Now, if I call these both x, what's the Pythagorean theorem say for this triangle?
Pythagorean Theorem.
For this triangle, normally it's this, a squared plus b squared equals c squared. Okay, what's c?
There's a squared plus a squared is equal to 1.
Aha, and I called it x, so I'll call it x. Or if you want to call it a, whatever. A squared plus a squared equals 1. Okay? And we could say 2a squared is 1. Or we could say a squared is 1/2. Right? In other words, a is the square root of 1/2, which some people make you write like this. Remember
square
that?
root of 2 over 2.
So this is like 1 over root 2. Okay? But we can test to see if our original guess was reasonable, right? Because we said our original guess here is about 0.7. What's 0.7 squared? What's 0.7 squared? What's 7 squared?
7 squared is 49, so 0.49.
0.49. That's about 1/2,
Pretty
right?
far off.
No, 0.49 is 1/2.
Oh, I thought our
So
guess
it's
was
almo-
0.7.
It is, but all we're testing is whether its square is 1/2. Because that's what we're looking for. We're looking for the square root of 1/2.
Oh, okay.
So how do you test to see if you find the square root of 1/2? You square the thing and see how close it is to 1/2. So this is pretty close, right? Okay. So 0.7 is not a bad guess. And actually, the square root of root 2 over 2 is like about 0.707, I think.
Square root of this.
What's the calculator say?
Square root of 2 over 2. 0.84?
Oh, you did the square root of the square root. Right? You typed this into the calculator. You did square root of the square root of 2 over 2.
Mm-hmm.
That's the square root of what we want. So square that. Do you know how to do answer squared?
So you just want this?
Yes. That's all they. 0.707. See?
Yes, that's better.
Well, there's a 1, right? 0.7071. Okay. So the point that I'm trying to make here is that the graph here is sort of like the unofficial way to do sine.
Okay.
Okay? The official way to do sine is to do that analysis that we used with the isosceles triangle.
Okay.
Right? So this is like the official value. Okay? Now, what you end up doing is you say, I know all the values of sine. I kind of have them memorized. And
Sort of.
you know, well, someday you will. We know that the values of sine, so you have to follow with the hand here.
Yes.
You can see from over there? Okay. The glare is not messing you up?
No.
All right. We know that sine, the important values of sine, go along a few chosen paths. So we have 0, that's an important value of sine. 1/2, that's an important value of sine. Square root of 2 over 2. And then what's this other one? You mentioned it earlier.
Square root of 3 over 2?
Yes. So actually, if I want to say this is 0, and this is 1/2, and this is root 2 over 2, and this is root 3 over 2, these are sort of the important values of sine.
Okay.
Right? And there's actually a very simple way to memorize this. So look at this. If I, instead of, let me erase that last one. I'm going to use for this last one, here, it's better if I just do root 4 over 2. So if I just do square roots of 0, 1, 2, 3, 4, all the way up, and put it always over 2, I actually get the right answer, right? Because square root of 0 over 2 is 0.
Okay.
Square root of 1 over 2 is 1. Right, or square root of 1 is 1. Right, so these are like the official values of sine that we know from studying the unit circle. Right? I'm
Whoa.
gonna actually delete that there. It's not letting me erase.
Evil eraser.
I know. Anyway,
You should just get the...
these values right here, which I will write more neatly. 0, 1/2, root 2 over 2, root 3 over 2, and 1 are like the important values of sine.
Okay.
Okay? And of course this happens at 30 degrees, 45 degrees, and 60 degrees, 90 degrees, and 0 degrees. Okay?
Okay.
So in other words, if you remember that these are the official important y values, and then you know that kind of like, all right, right here on the graph I'm hitting the first official important y value. Right here on the graph I'm hitting the second official important y value. Official important y value number 3, and finally important y value number 4. Right? Okay, now I can look at what happens on the way back down, right? So this is 90, and then we got 120. We'll call this 135 and 150. I'm gonna trace back over the official important y values as I move back down the graph. Do you see what I'm saying?
Yes.
Okay, so what's this one? This is 1.
Yes.
This is the next official important y value going backwards, which is what?
Root 2 over 2?
Nope. It's this one right here. Root 3 over 2.
3 over 2.
Right, root 3 over 2, root 2 over 2,
Over 2,
root 1 over 2, root 0 over 2. Right?
Right.
Root 4 over 2?
What's root 0? Does that even exist?
What number do you multiply by
0.
itself to get 0?
0.
Okay, so it's pretty easy actually, right? So what's root 4 over 2?
Root 4 over 2?
Is what?
1.
1. So that's why we go 1, root 3 over 2, root 2 over 2, root 1 over 2, root 0 over 2. Okay, does that make sense? That's like how you memorize it. As I go up, I go 0, 1, 2, 3, 4. 3, 2, 1, 0.
Okay.
But it's not so simple, because actually what I'm doing is I'm doing this square root of 0, square root of 1, square root of 2, square root of 3, square root of 4. Which really is 0, 1/2, square root of 2, square root of 3 over 2, and 1.
Okay.
Does that make sense? How to
Yes.
memorize it. Okay? Now, we actually ought to be able to finish out all the answers, but let's do it in a different video.